Hello everyone, I'm Sunanta from SNS College of Technology, Department of Mathematics. So here in this lecture video series, we are going to see what is distributions and how we can apply that in real life. So as in this video, we are going to see how to apply the concept moment generating function based on DT content, that is design thinking based lecture video. So here in probability theory, moment helps us understand the characteristics of random variables. Measures such as mean, variance, skewness, kurtosis provides valuable information about the distribution of data. So in this we are going to learn what is a moment generating function, how it helps in finding moment of a random variable, its application, a design thinking based activity and a real world application. So first is the concept introduction. So that is before understanding moment generating function, let us recall the concepts of moments. The first moments represents the expected value or mean of a random variable. So the second moment helps us determine the variance, so which measures the separate data around the mean. Next, a moment generating function, commonly known as MGF, is a mathematical tool used to generate the moments. For a random variable x, the moment generating function is defined as mx of t equal to e of e power tx, where this mx of t represents the MGF, e represents the expectation, t is the parameter, and x is the random variable. So therefore, E of mx of t is equal to summation e power tx p of x equal to x. Similarly, mx of t equal to integral e power tx f of x dx for continuous type of functions. So similarly, we can write variance of x, covariance, standard deviation, etc. So here is the moment generating function. So explanation. So let us consider a simple example. So x is a random variable representing the number of successful outcomes in an experiment. So using the probability distribution of x, we can construct its moment generating function. So after obtaining MGF, differentiating it once gives the expected value. Next, differentiating it twice helps us get the second moment. Therefore, instead of calculating each moment separately, the MGF provides a systematic approach. So this makes moment generating function a very useful in probability distribution such as binomial, Poisson and normal. Next is the design thinking based activity. So predicting a student's academic performance using moment generating function design thinking process. So first one is empathize. So students often analyze their marks, attendance and assessment scores but find it difficult to understand overall performance patterns. So next we can apply define. So where he can or how can we statistically analyze student performance data limit and predict the variation in their marks. Next is an ideate part in which we can apply the internal marks. Like for example, there are 5 students and their marks are 75, 82, 68, 90 and 85. So using this probability MGF function, we can find the average performance, that is mean. Next is the score variance, that is also known as variance. Next is the distribution pattern, that is MGF. So next is a prototype in which the mean performance level, variance in marks, performance consistency are calculated. Next is the testing part. So comparing the predicted statistical results with actual student performance, we can get the outcome of student, how he understood the concept and how he is applying it in the day-to-day life. Next is a real world application. So we can use this in a case like quality control. For example, moment generating function are widely used in industry quality analysis. So consider a manufacturing company producing electronic components. So each component has a lifetime measured in hours. For example, if a bulb, we are considering a bulb, it can glow for around 2000 hours like that. So the company collects failure time data from thousands of components. So using probability distribution and MGF, engineers can analyze average lifetime of components, variation in the product life, probability of failure within a given period. Next, for example, if the lifetime of component follows the probability distribution, MGF helps engineers calculate the moments. So the mean lifetime variance indicates the reliability and consistency. So based on this analysis, companies can improve product design, reduce the failures, plan maintenance schedules, etc. So next, let us see the applications of moment generating function. So this is applied in various fields, like in different areas. Like here we have seen quality control, so it can also be applied in data science, artificial intelligence, reliability engineering, and risk analysis also. So here is the short recap of or mind map of what we have seen in this video. Initially we have seen what is moment generating function. After that we have seen the formulas, etc. Then how to apply this moment generating function in real life. Next, the example with real life application. Next is in assessment. So in which MGA formula is what is the fundamental definition of the moment generating function MGF, and its random variable. So it is E of t power x. So next is how the kth moment of a random variable x denotes. So its answer is the process to find the specifical derivation. Yes, here are the reference links, and thank you.